Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to be showing you how to write a molecular complete ionic and net ionic equation for a chemical reaction. In this video we'll be looking at zinc chloride reacting with mercury 1 nitrate. If this is your first time to my channel, welcome, and if you like this video or if you like this channel, please subscribe and put a comment in the comment section to like the video. Okay, now with that out of the way, let's get into this. So, so here we have zinc chloride reacting with mercury 1 nitrate. As you can see, they're giving us the names. So we have the names here and not the formula. So you have to know how to name your ionic compounds. If you are struggling with that, please see my videos on naming ionic compounds. I also have a video on naming acids as well. So I'll link those videos down below. Also, we'll go over how to name these in a moment, but you'll probably want to check those out. So with regard to zinc chloride, so the way you want to understand this is remember that the name of the substance is just the two names of the ions put together. So we're going to be going backwards. So if you notice that we have two parts of the name, the first part is one ion, this is another. So zinc ion and chloride ion. So we need to figure out the names, the symbols for those, and write the charges. So zinc is Zn. Zinc is one of the exceptions to the rule when it comes to transition elements. Normally, when we think of transition elements, they can have multiple charges, and so you would need to use a Roman numeral in order to identify the charge. But here, there's no Roman numeral, even though this is a transition element. This is because zinc has only one charge, and that's a 2+ charge, and that's just something you have to memorize and know. So zinc is a 2+ charge. And chloride, that's going to be Cl, and that is a -1 charge. And how do I know that's a -1 charge is probably what you're wondering. And the reason I know this is a -1 charge is for two reasons. One, there's the rule that if you are in groups 5A through 8A, if you're in any of those groups, then the rule would be the negative charge of your ion is the group number that the element is in minus 8. So if you're in group 5A, then 5 minus 8 is -3. If you're in group 6, then 6 minus 8 is -2. So here, chlorine is in group 7, so 7 minus 8 is -1. The other way you could do this is just by thinking about what's going on in order for the chloride ion to have a -1 charge. So this goes back to your valence electron. So, and this is the better way of remembering. So if you can remember what the valence electrons are for the element, then you can remember, okay, how many elements does this need to lose or gain in order to get that full outer shell? Because all atoms are trying to get that full outer shell, that valence shell. And so if you know the valence electrons, that helps. So we know that from the periodic table that the group number for the main group elements, 1A through 8A, that group number tells you the number of valence electrons. So if you're in 8A, then you've got 8 valence electrons. If you're in 5A, you got 5 valence electrons. And if you're in 2A, then you've got 2 valence electrons. So chlorine is in 7A, so that means it has 7 valence electrons. And so what does that mean with regard to that octet, that outer shell? Well, it's typical for chlorine to want to gain another electron because it has 7 valence electrons. It just needs one more electron to get to that outer shell, that complete full outer shell, which is usually 8. And so it'll gain that one electron, and that one negative electron being gained gives it a -1 charge. And so that's another way that you can remember. So now that we know the charges on the ions, chloride has a -1, and zinc has a +2. And so now we need to write the formula. When you write the formula, you need to make sure that the charges are balanced. So you can see that I need 2 chloride ions to balance the charge on 1 zinc atom. So I'm going to need 2 of these. The other way you could do this is by using the crisscross method. So here I have a 2. I can crisscross, write that as a subscript 2. Here I have a 1. That's going to go as a subscript for the zinc. So crisscross. So I'm not going to write ones. We don't write ones in our formulas. So we're just going to put Zn for zinc and then Cl2. So there's my formula for the zinc chloride. And then I would do the same for nitrate. So mercury 1, I need to know the formula for mercury 1. Now, mercury 1 is one of those special ones that you got to remember. So you might think that mercury 1 is Hg, and then the 1, you would be correct. That's the charge of a +1. So this is what you might think would be the ion, but that's really not the form that the ion comes in. The actual form that the ion comes in is Hg2 with a 2 plus charge. So Hg2, so you have 2 atoms of Hg together, and both of them have a 2 plus charge. So if you split the charge between the two, they each get a +1. So that's why it's called mercury 1, even though there's a 2 plus charge. That 2 plus charge is being divided divided between the 2 atoms. So each atom gets a +1 charge. So that is your mercury 1 ion. Your nitrate ion is a polyatomic ion. And so you need to know the polyatomic ions. And you probably have a sheet of the polyatomic ions from your teacher. So these are ones you're going to have to remember. You're going to have to remember the formula, as well as the charge. I have a video for polyatomic ions. I go over what patterns to keep in mind that will help you to remember more easily the polyatomic ions. I'll link that into the description as well. So nitrate is NO3, and that has a minus charge. And so once again, you have to balance the charge. So again, this has a -1, this has a +2. So I'm going to need 2 nitrates to balance this. And again, you could do the crisscross method, right? So the 2 would be a subscript over here, and the 1 would be a subscript over here. We don't write the 1. So the way this would look would be Hg2, and then parentheses NO3 2. So this would be the formula. Now you're probably wondering, well, look, Mr. Koval, I was taught in class that we should, when we have these numbers here, we need to make sure that they are the lowest whole number ratio. So I should reduce this to 1:1. And normally you would be correct. But since this ion is actually Hg2, that really is the way that ion exists. So we don't want to reduce that. Okay, so that stays a 2. So that means that stays a 2. So this is the formula that we're going to keep. Okay, so this is just one of the ions you got to remember its funkiness. So I hope that helps. All right, so we have our formulas of our reactants. Now all we need to do is get the products. And since we have 2 ionic substances, that's a dead giveaway that you're going to do a double displacement reaction. So how do you get the products from a double displacement reaction? Well, I'm glad you asked. So in this case, what you're going to do is you're going to take the ions from the inner part, the inner ions, put those together, and then put the outer ions together to form another product. And so when you're doing that, you got to make sure you balance the charge again. So we have zinc, which is a 2 plus charge, and we have nitrate, which is a -1. So we're going to need 2 nitrates to balance the +2. So here we're going to have Zn, and we're going to have parentheses with 2 nitrates in there. Okay, so that's one possible product. And so now we're going to take the the mercury 1 ion and the chloride ion. Now remember, this has a 2 plus charge. This has a negative 1 charge. So we're going to need 2 chloride ions. So here we go. So that's going to be Hg2Cl2. Okay, so now we have our products. So now what's left is make sure the equation is balanced, and then we're going to identify the states of matter. So let's balance first. So we have 1 zinc here, 1 zinc there, balanced. We have 2 mercury here, we have 2 mercuries there, balanced. Okay, we have 2 chloride ions, we have 2 chloride ions, that's balanced. And then finally we have 2 nitrates and we have 2 nitrates. Everything is balanced. Easy peasy lemon squeezy, right? Okay, so now we have this balanced equation. We need to make sure we have the states, the correct states. So normally these are going to be aqueous, but let's make sure. So when you're trying to figure out what state your ionic substance is in, it's either going to be aqueous or solid, a precipitate usually, and that's going to be over on this side. But it could be a solid on this side too. So that's when we use our solubility rules. So your teacher probably gave you solubility rules. You could find them on the internet really easily. So the solubility rule. So let's look at zinc chloride. So chlorides, according to the solubility rule, all chlorides are soluble except when. So when you have a silver, or when you have lead 2 ion, or you have mercury 1 ion. We only have zinc here, so this is soluble, so it's aqueous. Here we have mercury 1 nitrate. What does it say about nitrates? It says that all salts of nitrates are soluble, no exceptions. So this is aqueous. So far so good. Okay, what about zinc nitrate? We just read that all nitrates are aqueous, so this is going to be aqueous. All nitrates are soluble. And what about this chloride, this mercury 1 chloride? We just read that all chlorides are soluble unless it's paired with silver, lead 2 ion, or the mercury 1 ion. And here we have the mercury 1 ion. So this is a solid. It is insoluble. So there is our balanced molecular equation. So now we can do the ionic equations. We're going to do the complete ionic equation and we're going to do the net ionic equation. So first, the complete ionic equation. When you write your complete ionic equation, you're basically taking all the ionic substances that are aqueous and splitting the ions apart, writing them separately. And so that's what we're going to do. So we got zinc chloride here. So zinc is a 2 plus charge, aqueous. And I want you to notice that now I'm writing the charges. When you write the ions together in their formulas, you don't write the charges. But when you write them separately, you write the charges. Okay, so here we have chloride ion. Notice we have 2 of them. So if you have a subscript for your chloride, for your ions, then that's going to become a coefficient. So we're not going to write that as a subscript. If I write that as a subscript, then that would be like chlorine gas, and that's not what we have. So the subscript would indicate that those 2 chloride ions are bonded together, but they're not bonded together. They are ions. So we don't want the subscript. We want the subscript is going to become a coefficient, and we're going to write the ion charge. So there you go. That's 1. And so now we can do this one. So we got to separate these. Again, the mercury ions, even though this is a subscript, we're not going to write it as a 2 because Hg2 is its own ionic complex kind of thing going on. So we got mercury, that's going to be 2 subscript, and it's going to be 2 plus charge, and then aqueous. And then the nitrate, now this one has a 2 subscript, so that's going to become a coefficient because We have two of them, so two nitrates, NO3 minus aqueous. And now we're going to do the same thing for our products. So again, zinc nitrate is aqueous, so we're going to split those apart. So zinc 2 plus aqueous plus two nitrates, so 2NO3 minus aqueous. And then, of course, this is a solid. Anytime you have a solid, liquid, or gas together, you're not going to split that apart. Keep it together. So there we go. So we have Hg2Cl2 solid. And the reason we're going to keep that together, because in reality, those ions are actually bonded together in a solid. They're not going to be apart. So everything else is separated. So this would be our balanced ionic, complete ionic equation. So CIE. And now the last step is to figure out what the net ionic equation is. And remember, the net ionic equation is where you have the spectator ions removed. And what are the spectator ions? Those are the ions that are not involved in the reaction. They're not doing anything. There's no change. And so there's a couple of ways you can go about identifying the spectator ions. The first way would be you could look at the product that's formed. So here we have a solid product. The ions that are involved in making that product are not spectator ions. They're part of the reaction. So those are going to stay. So that would be mercury 1 ion and the chloride ion. So those would stay. The others would go. The second way that you could figure this out would be look at what changes and what stays the same. If you look at an ion on the reactant side and you look at the same ion on the product side and they are exactly the same, no change, it's a spectator ion. So here we have zinc 2 plus aqueous, and here we have zinc 2 plus aqueous. That's a spectator ion, so we could get rid of that. And here we have 2 chloride minus aqueous, but here it's part of a solid, so there's a change. We're going to keep that one. That is not a spectator ion. Same thing for the mercury 1 ion. Mercury 1 ion is part of the solid, so it changes from aqueous to solid, so that is a change, so that stays. But the nitrate goes from aqueous and it stays aqueous. We have 2 nitrate ions here and we have 2 nitrate aqueous ions here. So that is spectator ions. So those are our spectator ions. So the last step is to write everything except for the spectator ions. So we have 2Cl minus aqueous plus Hg2 2 plus aqueous, and that's going to form our Hg2Cl2 solid. And there, ladies and gentlemen, is our net ionic equation. I hope this was helpful. I hope you enjoyed this video. If you learned from it and you enjoyed it, please make sure you hit the like button. Please subscribe to my channel and hit the notification bell so you can be notified of other new videos that I put out. Put a comment in the comment section. Let me know what you think and if you have any questions. Thank you for joining me and have a great day.